welcome back to the Pair Program. I'm your host, Tim Winkler, joined again by my co-host, Sean Leahy. Sean, good to have you back, man.
Great to be here, Tim.
Yeah. We surveyed the last episode, and it seems like the results are positive. So we're keeping you in the mix.
I get to keep my unpaid job.
Unpaid job.
This is fantastic. I'm stoked. We keep having on these killer guests and everything, and excited to be a part of it. How's college football season treating you, Tim? How are you feeling as we get into real fall here?
Yeah, go Vols, right? I mean, for me, it's a bandwagon fan. I went to George Mason, so nothing really to root for beyond a crazy, Final Four run back in the day. But do you have a team in the mix, Sean?
I'm just here for the chaos, right? Like we're seeing head coaches getting fired already. We got Indiana as a top 10, top 5, top 3 team. It's so much fun, and I'm just here for the party, I guess.
It's a horrific and vile season. Michigan is so bad. They're so bad. Absolutely satanic. It's unforgivable that they aren't contending every single year.
Like, for those of you listening to the podcast, that's one of our guests, Michael, and I'm feeling really good now about some of the opinions and hot takes we're going to get today. Outstanding.
I'm so mad. How are you Michigan and you're unranked? Like there are like 15 to 20 teams that should be contending every single year, and if you're not, it's just horrible.
Yeah, coaches getting axed.
It's just horrible.
Yeah, they don't have the patience for it. Well, shit, man, I didn't know we could riff on football all day, but I think we do got to get around to the episode. I wanted to ask you a quick power theme question, Sean. So when's the last time that you actually had to buy batteries, and what was it for?
Oh, no, so I still got a little bit of the my dad's Oregon lumberjack in me. And every year I'll go out to Home Depot and drop a little bit of cash on some D cells and some double and triple A's. Make sure all the flashlights are tuned out, the lanterns, just in case. So I'm loaded up. Okay,
the D cell is going big dogs. Yeah, I was thinking about this. It seems like it's kind of an old fashioned industry. I use them quite a bit for my daughter's toys. I feel like everything that she has like either talks or makes a weird movement, and so they have like 6 AA batteries, but they last about a week, and then you got to replace them. But beyond that, it seems like everything's kind of rechargeable. So I had to really think about what other products, people are using.
But is that enough, Tim? That's the question, right? Do we have enough power?
That's the question. Good cue on the intro. On that note, let's give our listeners a quick preview of what's coming up. So on today's episode, we're going to be diving into a challenge that maybe doesn't always kind of center the headlines, but it powers everything else that does, which is energy on the modern battlefield. And so we're talking about how the next generation of defense tech, autonomous systems, Counter-UAS, directed energy weapons are kind of pushing our power infrastructure to its limits. And how do you kind of fix some of these issues when it comes into a power shortage? You build smarter, quieter, more flexible power from the ground up, and that's what our guests are doing today. So we've got Adam Warmoth, founder and CEO of Chariot Defense, a company designing high voltage hybrid electric power systems built for the tactical edge. And joining him is Michael, I'm going to go for it, LaFramboise.
You're close. LaFramboise. So there's an E after the S, so you pronounce the S. It's
LaFramboise.
Yeah, it's like an index -1 thing for the French for what you pronounce and what you don't.
I feel like I get like a B+ on that though. It's pretty close.
It's good.
Co-founder and CEO of Aurelius Systems, a team behind a new generation of mobile autonomous laser platforms designed to take down drones at a fraction of the traditional cost. Together, they're tackling the same problem from 2 different sides. One's building the power, the other using it to fuel the future of defense. So Adam and Michael, thank you both for joining us on the Pair Program.
Thanks for having us.
Thank you. My toys are kind of like your daughter's toys, except I need a little bit bigger batteries,
That's right.
It's kind of the deal. Yeah.
little bit more dangerous toy, I'd say as well. Now, before we dive into the deep end, let's go ahead and kick things off, a little icebreaker that we call Pair Me Up. We'll kind of go around the room, spitball 2 things that go together. It could be serious, funny, random, kind of dealer's choice. Sean, why don't you kick us off?
So yeah, I've been thinking about this one a little bit. I think it's going to be a little more controversial than I originally planned, but mostly because Michael's here. My pair is coffee for long drives, or coffee and long drives. And the reason this is my pair this morning is I recently had to drive through West Virginia for a couple hours over a weekend, and I really just was in the zone with my my cup of coffee and driving. But I texted my brother afterwards, and he goes, "I could never drive with a cup of coffee. I'd be pulling over every 10 minutes. I'd be too wired." He's like, "My drink of choice when I'm driving long road trips, just some water, maybe a Coke at the most." So I hope I'm not ruffling too many feathers with that. But if I'm really putting in some miles, I'm getting like a good Wawa cup of coffee and just hitting cruise control, enjoying it.
Yeah, I'm 100% on board with that. If it's in the morning time, my afternoon go to though is usually a tall boy of like a Coke on tap, cherry Coke on tap, just a little treat yourself on a road trip.
Tall boy. So like,
60,
yeah, like what?
Like a 64 ouncer. Yeah. Which similarly, you're going to be doing a couple of pit stops along the way, but yeah, I feel like it's an opportunity to treat yourself when you're on a road trip.
Our first big exercise out of JRTC, we had to drive 30 hours straight from San Francisco to Louisiana. Operations and me switching off, driving and sleeping. We had to get pretty creative on our beverage strategy there. So.
But a lot of caffeine.
Oh
yeah, I dig it. All right, good stuff. I'm going to jump in. I'm going to go with Wisconsin and cheese curds. So recently took a trip to Green Bay with a few buddies for a friend's 40th, and we went to the Commanders-Packers game, Thursday night football. Great experience. Lambeau was epic. Energy was electric. The fans were ridiculously welcoming, by the way, too. Like the nicest fans I think I've ever experienced. Just really, encouraging, interaction with the opposing team. You don't really see that too often. Shout out to Philly on horrible fans. But I would say that every Wisconsinite that we ran into was, have you had the cheese curds? That was like the question. And so the trip wasn't complete without housing cheese curds, and I would say that they were fantastic, super healthy for you as well. And that's my pairing: Wisconsin and cheese curds. Redskins got their asses handed to them in that game, by the way, but that's what I'm going to go with. I'm going to pass it along to the guest, Adam. Quick intro on your pairing.
Yeah. So I'm going to do sunshine and baseball. Grew up in the Bay Area, in the Barry Bonds era. I now live a 5-minute walk from the Giant Stadium. And can actually see the Jumbotron from my apartment. So,
wait, Adam, you live like near Mission Bay? You live in there?
Oh, yeah. Yeah.
Dude, you're like 2 blocks from you should just come hang out at our office.
I know.
Yeah.
So love that area. Up in South Beach there. And then, just love walking along the water there. It's a great stadium on a sunny day. So yeah, sunshine and baseball.
That's sick. Growing up in the Bonds era too, man. That's epic.
Yeah. I had the rubber chickens for the pitch to berry and all that fun stuff. So
that's cool. That's cool. Do you go to a lot of games, or you just kind of just watch them from your apartment because you kind of see everything right there?
Yeah, exactly. Yeah. I mean, founding a company doesn't leave a ton of free time for baseball games, but try to still make it to a couple.
Good stuff. I like it. Michael, how about yourself? Quick intro and your pairing.
Yeah, for sure. I'm Michael LaFramboise, co-founder and CEO of Aurelius Systems, a laser weapon systems company for counter-drone applications. I would say my pairing is... You guys are all such good people. Everything's so like homely and great. I'm gonna say color and like bright out there colors and defense tech logos in marketing.
Oh, nice.
Which is not the thing. Have you ever seen like Lockheed, Northrop, and all these company logos like stacked up? It's just black on white.
Yeah,
it's just black on
white. Or
white.
like a navy blue.
Yeah,
there's definitely an aesthetic revolution going on, which I like with the new defense tech entrance. That we got some cool like 1980s theme stuff. You got some guys rocking mullets and the bandanas.
Dude, the mullets are sick.
Big, day glow colors. It's a vibe, as the kids say. It's a vibe.
It's a vibe.
We did do a rebrand. maybe 6 months ago or so. But before, our logo was like Miami Vice, basically colors, or like Hotline Miami. So it was like pink, like hot pink, electric blue, and the yellow as well. And then I think that was actually a little bit too much. So we just switched to MAGA red.
Something way more baseline.
Way more subtle.
Yeah.
Yeah. Actually, we're having the CEO from Defense Unicorns on, and it's one of those like things of swag where I was like, I had to get a shirt for my daughter, but it was like, you don't really see. Yeah, you don't really see like that kind of branding in defense. I was like, man, they had a line like at their booth, just, hey, can I get a shirt for my kid? I was like, this is pretty cool. But yeah, I dig it. You're right, man. I think we need some rebranding happening across some of these defense tech startups and brighten it up a little bit. Cool. Well, thanks again for joining us, guys. We're pumped to jump into the heart of today's discussion. So let's dive in. I want to kind of begin with the battlefield energy scenario, the landscape. Adam, I'll start with you on this. So within like the bigger picture around counter-UAS, it feels like this threat has evolved quickly. Drones are cheaper, smarter, showing up everywhere. When you look at this from a power and infrastructure standpoint, how do you kind of see that problem set changing?
Yeah. And so, I mean, the idea for Chariot really came from my time as the program manager for Counter-UAS at Anduril. Was seeing kind of this evolving threat, started running that program kind of pre-Ukraine war. And so, people were talking about the drone threat, right? But I don't think a lot of people had really internalized how much this was going to change warfare and change the battlefield. So we kind of had a front row seat to that, working with SOCOM as their systems integration partner for Counter-UAS, deploying technology into theater, and seeing where we were hitting our limiting factors. And what I constantly realized was, in this environment, traditionally air defense has been this kind of brigade level capability. So something happening, managed by kind of a higher level. And so individual units, kind of smaller units, didn't have to worry about counter-UAS. They didn't have to worry about electronic warfare. Didn't really have to worry about ISR. We were operating kind of in an uncontested environment. And so, those capabilities were just kind of treated as happening on fixed sites, happening kind of in the rear, kind of creating these large kind of denial bubbles of kind of safe operations. And with especially the proliferation of small UAS, that assumption has gone away. We need to be deploying counter-UAS systems at the edge with small units. And as we started to do that, as we started to field advanced compute systems, advanced countermeasures, advanced sensor systems, we constantly ran into was problems with power, and problems with the mobility of the power assets available, problems with supply chain and logistics and resupplying those systems, and problems with signature management, where we're not operating from fixed sites where everyone knows where we are. If they find you, now they can target you. And so those big challenges we had with power led me to creating Chariot.
Yeah, why don't you just expand a little bit more on Chariot, a little bit about where the company's at this point, and maybe just a little bit of an overview on the product technology.
Yeah, certainly. So Chariot is building the solutions to that problem. Anyone who's got a Tesla and a Powerwall in their garage has way more advanced power technology than what's being fielded with DoD. You talked about, kicked off with talking about the story about the AA batteries, right? That those like non-rechargeable primary batteries are actually still like widely used in DoD. Everything's kind of stuck at low voltage, like, in often cases, lead acid batteries. And then if you need to start to go up to some of these higher power levels, you're going up to a generator. The other, pairing that I was going to make was, diesel and batteries. We think hybrid is the way, but taking advantage of some of these advanced batteries that have been developed in the past 20 years. There's been some recent articles by folks like Packy McCormick on just the crazy advancement in core power technologies and silicon carbide power electronics, high voltage battery packs, microcontrollers, and power electronics, and taking advantage of that technology breakthrough that's been happening in companies like Tesla and Apple and Archer and Joby that just hasn't translated over to DoD. So that's really the core of what Chariot's doing, is taking these advanced high voltage power systems, advanced power electronics, advanced microcontrollers, and building compact, robust, high performance, safe power systems that can deploy to the edge, can deploy in mobile form factors, and can enable Counter-UAS systems like what Michael's building to actually be deployed to the edge and be used to effect.
Yeah, I got some questions teed up about your past too, because working at companies like Archer and Anduril obviously played a big part into that journey into what you're building today. But Michael, let's loop you in at this point. So you're kind of on the receiving end of that equation, kind of turning this power into capabilities. How big of a deal is this kind of mismatch between modern tech and legacy power for you all?
Yeah, for sure. I mean, basically what our system does is we have an edge deployed autonomous turret to counter Group 1 and Group 2 UAS at distances that you basically have to spend like $2 million on a missile to get to in any kind of mass attackable way. And so what we do is we provide this, extremely low marginal cost to defense when you go out. Well, the Army acquisitions officers really, when we're talking about how we address like a drone swarm, for example, you can't spend, hundreds of thousands of dollars on even like an Anduril drone or for single shoot down, right? And that's even if you can get enough out there. So what we do is we turn the electricity that you're generating from your alternator or a battery system, if you have it on board, into ammunition. And you're able to essentially destroy drones for like 10 cents, 25 cents, something like that. It's just you're essentially, using a welding or a cutting laser that's used in industrial applications and turning it into a weapon system specifically for machines. So that's what we do. There are two main things in supply chain that we're really concerned with. So one we probably won't get to too much in here is the laser system, where we make industrial laser systems, but there aren't that many companies that make them in the US. So we'll probably go and make them ourselves. That's one. And the other one that we are definitely not equipped to make ourselves, and so we would rely on partners like Adam's company, is the actual power, like our magazine, right? And so what we do right now is we essentially work with like a series of companies, try and get the demonstration, show that we can use these battery power systems on the edge. And Adam and I have been to several demos together. Our team has partnered for the DoD several times. I think at one or two of the JFIXs. I think it was just one, and then at Northern Strike we were working together at a recent demonstration. So
that's cool. Yeah, that's a part of this conversation I want to dive into is some of those demos collaborating together. But while we're on the topic, how much kind of cross learning happens between your team and Michael and Adam's team? Like, it seems like obviously you're addressing different halves of the same challenge, right? And so how much of that kind of like cross learning is a part of the build process for you all?
Yeah, I think it's a lot. I mean, Adam's team was in our office, I think, a couple of weeks ago, because we're working on the power handoff. So there are some salient things that go down with like the voltage requirement, the C drawdown rate, that are probably different from a lot of other applications, because we don't draw too much power in the aggregate, like the magnitude of power that we're drawing from the capacity. But we draw down very large amounts at short bursts. And so that's something that our teams have worked together on managing.
Yeah, Adam, anything that changed like how you approach your own product based on the collaboration?
Yeah, I mean, exactly. So, we really, try to push the story of batteries as power, not batteries as energy. And kind of that's where I was saying the diesel and batteries, perfect pairing is fuel is incredibly energy dense, but converting that fuel into electric power and having to do that at the time and point of use becomes incredibly limiting. And so with these really high power density power electronics, battery systems, it's actually a perfect pairing for an application like directed energy, where we can pull power from your source of generation, where your generation is sized to the average load. And as he said, it's not that much energy over the course of a day, of a week, of a month, but it's that really high peak power demand. And so sizing and understanding what that peak power demand is going to be is what sizes our system. It's what sizes that peak power capability. It's what sizes the battery to be able to handle that kind of surge of power. What sizes our thermal management system. And so getting that real field data on, what is that power draw? What are the characteristics of that power draw? There's things like power factor that matter. There's things like power quality that matter. And so actually testing that with a system that is the kind of perfect application for our tech, right? That hybridization where you can handle those big surges of power, and then just kind of keep backfilling energy from your fuel, just creates kind of the perfect pairing. So batteries and diesel, Chariot Systems and Aurelius lasers, another great pairing there. So yeah, we've learned a ton from actually just characterizing, understanding, and using that information to size the right components for our system.
Yeah, I'm curious on from your background, Adam, Tesla, Archer, some of these commercial EV ecosystems, how much of that has really kind of changed advancements in battery and battery and power distribution?
Yeah. So I'll go a little kind of nerd deep dive here on specifically one of the great breakthrough technologies. There's a lot of focus on, lithium ion batteries, right? Critical minerals, right? That gets plenty of play in the media as kind of a key enabling factor for these, advanced electric vehicles. What gets less focus is those power electronics. And so there was a invention of these silicon carbide power electronics, which allow you to do kind of software control of power at much higher voltages and higher power levels than traditional silicon power electronics. And so what that allows you to do, in the example from the EV world, Tesla was able to cut the size of their drive inverter that takes their battery power and actually use that to drive the wheels. And they're able to cut the size of that component by a factor of 10 from the 2012 Model S to the 2017 Model 3 with better performance. And so there's been some crazy material science breakthroughs driven by some really impressive research happening here in the US that has been a kind of key enabling factor for us. And so that's where these big commercial breakthroughs in these technologies, in these high voltage batteries, driven by and then scaled by. And that's the great thing about those industries as well, is not only have they invented amazing new technology, the cost pressures of automotive mean massive scale and massive decrease in cost. So you're seeing a massive increase in performance and a massive decrease in cost. So the ratio of those two things is then double impressive in terms of what that enables. And that's been all happening in the commercial world. And so companies like Tesla, right? Companies like Apple with their SPG project, Archer, Joby have been developing this technology, but it's been happening in Silicon Valley, kind of disconnected from the traditional primes, disconnected from the traditional OEMs. And it's just been happening in kind of the past 10 years. And I kind of think about, the role of Chariot as bringing a lot of those technologies into the defense space where, companies like Tesla and companies like Apple, which are our industrial giants, right? In preparing for World War II, our industrial giants were GM and Chrysler and, Freedom's Forge and the Arsenal of Democracy, converting kind of American consumer demand into wartime production. We don't have that luxury with our industrial giants today because of the conflicts with those companies and their presence in China, both from a sales and production perspective. So what we're trying to do is take all those technological breakthroughs, but bring them into the defense industrial base.
So, Adam, to follow up on that, one of the big themes on the podcast is the idea of dual use, right? Of technologies that have both defense, national security applications, but also growing commercial markets. And what we've seen a lot is that a lot of that can come down to timing, where you can have these commercial breakthroughs, like you just mentioned, for battery technology that are multiple years old or even decades old in some cases. And yet they're not making their way over to the defense market. So specifically, the question I have for you is, what do you look for in terms of timing and readiness when you're looking at the defense market and their ability to adapt some of these commercial technologies? What are the key things you look for that says, oh, okay, we could go to them now with Chariot and there's going to be that receptiveness for what we're bringing to market?
Yeah. So, one of the big, light bulb moments for me for Chariot was, the readiness of that technology for the electric aircraft world. And so, coming at this, from Archer and from Kitty Hawk and from Uber Elevate versus just kind of from Tesla, now you actually have components that have been built for FAA certification, which is going to match a lot closer to that kind of mil spec, what they're going to expect in terms of environmental performance, in terms of safety, in terms of certifiability, in terms of supply chain. So really the EV, but then the eVTOL industry, which also, borrowed and kind of took a lot of technology from the EV sector, but did that ruggedization and militarization they did the ruggedization and the kind of certification, and we're kind of taking that final step to militarization. So a much smaller leap than taking some kind of consumer grade technology.
Yeah, I want to kind of like keep on theme here with a little bit around, from going from like a demo into more of a deployment. And Michael, I'll jump to you on this. So, in kind of like doing more research on, you and your background, you've gone from prototype to live demos in under 18 months, which seems pretty lightning fast for defense. What has kind of allowed you to move at that pace?
Well, so speaking from automotive, I'll just do background really, really quick. I started my career as an engineer in the automotive industry. I worked at Chrysler for a while. I did mechanical engineering in undergrad, and I'm from Detroit and from the area. I went to Chrysler for a while, worked in these, like high scaling manufacturing systems for these for vehicles where you're running 400,000 units out of a factory per year. Worked in an engine plant, stuff like that. So got kind of a taste on like what you can extract in terms of pricing when you're making 400,000 massive robotic units per year. And it's probably a good idea to pull from industries like that if you want to do some quick R&D and deployment. But then I went to grad school and I went to Coherent, which is the biggest US optics primes, massive giga multinational optics company. I worked in research and development on high power laser systems for both material processing in the auto industry, and then a bit in directed energy as well. And then I moved into sales, and I would sell directed energy components into Lockheed and Northrop and some of these other companies in addition. So I worked in, basically I just worked in engineering and sales in this really niche industry where there's probably like 4 people in the country under 40 that have ever done that. And I thought about at that time when I left Coherent doing this company, 23, maybe 22. But that those systems that were being deployed at the time were like massive 300 kilowatt systems that cost like $200 million. And I used to make a lot of money selling the components for it, but I knew that we had massive margins on some of these products. And when you're feeding massive margin subcomponent suppliers into big systems for end prime integrators, everyone's taking a bunch of margin. And these systems end up just exploding. And a lot of things in the defense industry are like this. I just said this to the Secretary of the Army yesterday. I thought it was funny. Like, directed energy is like the wedding industry. And I'm sure a lot of other things in defense are like this, where as soon as you say an industrial system is for directed energy, the price 10x's and it's more complicated. And there isn't necessarily a reason to do that. So what we do at Aurelius is we actually don't pull components really from the directed energy industry. We pull it all from material processing in the auto industry. Those technologies have been scaled up. And like automotive companies, there's a massive price spread. It's like the opposite of defense in auto or in scale manufacturing. It's massive price pressure from the tier ones on all of the suppliers. Like Chrysler would have a massive buying ring in the basement. They put them in the basement. They had maybe 40 buyers, and they're all harassing suppliers all day, every day, just getting costs down. So that all came together. I left. I went to Amazon for a time, and then I went into my PhD, specializing in electro-optics at Columbia. But I dropped out after maybe a year, just seeing the drone issue. I was probably on the drone issue, like really convinced and compelled by it way later than a lot of these other people, including Adam, where Adam's thinking about it in like 2017. I'm in 2023 and I'm like, Ukraine war has been going on for a bit. This is really scary. I love my family and my country. I feel like, I can really do something about it. And especially when I was setting up factories, I'm really used to looking at pricing pressure and marginal cost. As long as your capital expenditures and systems are not too high, it's really a marginal cost equation for a buyer if you're going to produce anything at scale. And so I look at that and say, I can go and get a directed energy system out to market for way lower than these other companies. I know where the skeletons are hidden from my time in the industry. And like my marginal cost to destroying a drone is like a 10 million X marginal cost differential compared to legacy systems. And I'm like, that's compelling enough. We're going to go and do it. We're going to full send it. And it's not like we haven't had setbacks or anything, but I think, not overthinking things. Like I tell my engineering team all the time, like we don't want to do like the 130 IQ plus solution, do the 70 IQ and lower solution. And if it doesn't work, then we increase sophistication. and just run limited testing and see what it goes. And so because of that attitude, it's actually gonna make us take a little bit longer to get to market because we do that. But as we go to market, like in the coming quarters with these systems, we'll have something that like capital expenditure is super low, reproducibility is high, ruggedization is high. And it'll be more like an AK-47 of a laser weapon rather than like a 300 kilowatt massive giga system that breaks all the time and can't even fire very often. So
that's a cool journey. Yeah. No, it's a cool journey, and I love like how both of you kind of pulled on the commercial space to influence the direction and strategy for your build. Are there areas where you still kind of, this might be a layup, you still feel friction? What's like kind of slows you down when it comes to getting these systems actually fielded?
Yeah. Oh, I was going to say battery systems. Batteries. The one thing with pulling from the industrial laser system is that those lasers are made to run in an auto factory for like 200 hours straight or something, right? And so they're generally pretty bulky, which is something we can deal with, and we modify these systems to drop the weight and size for sure when we receive them. But what they are designed to do is pull like industrial 3-phase power. That's what they've been made to do. And as we go on, we're going to drop that as we get in more deep into laser modification. But for now, we basically pull the reason why they're cheap and producible, or cheaper than directed energy systems, is because they're made for these industrial applications, right? And so not many people make high voltage 3-phase drawdown batteries, that are that are deployed on the edge, like satellite manufacturers, and I think Chariot. I think that's kind of it. But
well, that's why I'm glad that Adam's here, paired up with you. You guys are feeling each other's pain points out right now. Adam, you were about to jump in. Sorry, I didn't cut you off.
So I mean, and I think the reason this part of the reason this problem has gone unsolved, has been that operating from fixed sites, and with these traditional 300 kilowatt laser systems, right? The thought was always this is going to be part of this big air defense bubble, right? This like large fixed site system that has effectively infinite logistics, and size and weight and cost don't really matter. And we're obviously seeing a shift in that, because of the small UAS threat. And so it's kind of very circular in terms of like, we need these now small lasers deployed to the edge because of that. So we need to go mobile. We need to go lower cost. And so that's really what's kind of enabled the opportunity for Chariot. One of the friction points for us is, power has traditionally been seen, because of that legacy model, as kind of a sustainment commodity. Like really just about, fuel and moving kind of bulk fuel forward and converting that fuel into just like locomotion, like in propulsion, right? And converting that fuel into kind of these massive generators at fixed sites, creating kind of grid scale systems. And so the actual conversion of that, fuel to electrical energy is just not tracked today by logisticians. Like they don't literally track like anything like a kilowatt hour. So like a fundamental unit of like the future of warfare, right? If we're talking about deploying a system like Michael's, the cost of that shot is measured in kilowatt hours, right? The ability to power that is measured in kilowatts. And so kind of shifting the mindset around power from a kind of sustainment and kind of just thinking about moving fuel around the battlefield to thinking about, we kind of think about like the weaponization of the electron, right? That's basically what Michael's doing. That's what these advanced, edge compute systems are doing, right? That's what these advanced sensors are doing. Is power is literally, part of the weapon system. And, without that power available at the edge, it becomes a paperweight. So kind of shifting that mindset around this, has been a challenge for us. But through the Army's Transformation and Contact Initiative has been kind of a double win for us. One is it's giving us access to get into there, to be able to tell our story, to be able to get, direct engagement with end users. It's also, though, exposed this problem. Traditionally, like, we talked about, Michael and us getting to actually go deploy on an Army range, months into the company. That was unheard of kind of in kind of traditional, legacy, the way that the department used to operate. And so now that we're fielding systems like Michael's, we're fielding like UAS systems, we're fielding, advanced EW systems. not just in like innovation theater demos where it's like 2 hours and everyone goes home and these kind of power problems don't become apparent. Now we're actually fielding those in operational exercises, force on force trainings, in those kind of, what is this actually going to mean? Not on day 1, but on day 7, on day 14. How are we going to sustain these systems? Michael was talking about that magazine depth, right? If you go into the fight with all your missiles and you fire them all, on day 1, you make it through day 1, right? But there's a lot of talk about the production rate of those missiles, right? If we're consuming a missile every time we have to shoot down a drone, not only is that going to be expensive, we're also very quickly just going to run out of missiles. And so really kind of the transformation contact forcing us to actually employ this new technology in real operational scenarios and not just in these kind of innovation theater demos, has been a huge accelerator for us as these problems start to become more apparent. And the need for technologies like ours and like Michael's become much more clear in that operational environment where we're talking about day 7, day 14, not just day 1.
I'm always curious, like when you show like operators, your technology, what's the reaction you get? Does it like immediately click on like how much that can change how they operate? Or, I'm always just generally curious when, you're interacting with an actual operator.
Yeah, from my side, I'll quickly jump in. We have what we call the power brainworm, which is like when we first talk to someone, they're like, okay, so like it's a battery. Like I already have batteries, right? Like, but if we manage to like, hold their attention for more than like 2 minutes and we start to explain how the integrated energy storage, the power electronics, how that all works together, deploys in kind of a single drop-in form factor, integrates with their existing equipment, allows them to operate with lower signature because they don't have to keep their generators running 24/7, allows them to operate 2 times longer because they don't need as much fuel with less resupply, right? Allows them to field systems that otherwise they'd have to leave at home because they didn't have enough power to support those systems. As we start to get into, and this is really kind of a lesson for, I think, for defense tech in general, is we try to spend like as little time as possible talking about the specs of our system and as much time as possible talking about how does this fit into your mission? How does this make you more lethal, more survivable, better equipped to perform your mission? And within, if we get 15 minutes with them, we get in the power brainworm and then they're hooked. So
I love that example, man. That carries over to so many different verticals, not just defense.
Adam is like a great advice machine right now, where he just went through mission impact with what he was talking about just then, as opposed to like checking off requirements from an RFP. So for all the defense tech founders listening, like that's exactly how you need to be thinking about bringing whatever your capability is to warfighters and not just trying to respond to a dusty old RFP. But Michael, any similar kind of lessons learned or approaches from when you're out there demoing?
Michael just puts on Star Wars. Just like, check this out.
No, I think when we go and to talk to a base commander to try and do a demonstration, right? They're basically like, I'd say most people we've been trying to deploy laser weapons for like 30, 40 years at this point. And basically every year it gets like $1 billion in R&D. And it's clear that the military is just going to keep dumping billions of dollars into it until it works. Like they're not going to stop. But a lot of people have been burned by some of these products that have come out, namely like the big systems, like 30, 50, 100, 300 kilowatt systems that have come out. Those are going to work. And I think that's a product that we would want to get into as well. But right now, what we can do is, at this point, we've done so many demonstrations and we have so many like memorandums from 1-stars that have witnessed our demonstrations we can go and submit. But in the beginning, we had to go to the JFIC's like open demonstrator at Camp Roberts. And I think Adam might have had a similar thing. Where in the beginning, when you first have R&D units, you're like TRL 3, 4, 5. There are these open demonstrators. I think there's one on the East and one on the West Coast that are extremely useful, and we're very thankful for those, where you can get your first field demonstrations. And at the beginning, people are like, I've tried a laser weapon. It's all like ARL, AFRL, like research lab stuff, integrated DARPA projects. Like the smartest people in the world are working on this. You're just like a dude in a garage. Like I had 2 employees at that point when we first did our JFIC's demonstration. And so I think for a lot of the recent company history for Aurelius Systems, we've been in like a customer education kind of mode. But now we're getting invited to like demonstrations that are at the same time on either side of the country. And like, we literally have to figure out like, I don't have enough systems to go and demonstrate against. And so I think we're at that point where we're finally getting over that hump. Luckily, when I say, hey, I have a laser turret, can you just give me some range time? Like generally people are like, oh yeah, that's freaking sick. Like, let's just try it.
Yeah, I just wanted to kind of close on what I've kind of seen is like, which just feels like a bigger theme in this bigger shift in defense tech, which is like smaller teams kind of building more modular, almost like software native systems that are solving real operational problems. And I think that's exciting. That's why I was really excited to have both of you guys on. But I always like to just kind of think forward, like let's say 5 years from now, what do you guys kind of see like the modern, almost like defense stack at the edge kind of looking like? Just freebie out there, Adam, if you want to kind of lead.
Yeah, I mean, we kind of think about kind of all these defense systems being really about fundamental technologies of like comms, compute, and power as like the lifeblood of like these robotic and autonomous systems. And so, like for a soldier, it would be like, water, MREs, and like tobacco and Zins. It's like for robots, it's comms, compute, and power. And so, we're attacking obviously one of those critical infrastructure layers, the Zin of warfare for robots. And
that's a shirt. That's a shirt right there.
Totally. I mean, that's gonna be the opener line of this episode.
Yeah, exactly. So we're really investing in that horizontal layer, right? Kind of some of the less sexy stuff, right? Compared to Michael. And then there's some really cool stuff being developed in terms of sensors and then effectors that are then be able to build on top of that layer. So cool. I think you're going to see continued innovation kind of in both of those areas. We're really excited to continue to innovate, and it's a very different business model around that, just like that horizontal layer that we can build these future systems and deploy these future systems on top of. And then there's also going to be really cool innovation on advanced sensors, advanced countermeasures, advanced effectors. And those are going to kind of build off of each other. And with a lot of the kind of advanced compute, now you're doing fusion between those systems, you're doing collaborative autonomy. So I think you're going to kind of see this kind of exponential effect here, where kind of each advancement kind of builds off the other. And so even though, the robotics stuff kind of happening in Ukraine is still, it's obviously dominating, but it's still kind of, people steering, drones over fiber, right? Like the advances in autonomy, and then the advances in the compute that can actually power that autonomy, and then the power that can power that compute, like it's all going to start to stack, and you're just going to see, I think, kind of a kind of fast takeoff of this, even more so than what we've seen in Ukraine, of just like that push towards advanced deployed autonomous systems, robots making first contact. So it's going to be pretty interesting to see what happens over the next couple of years.
That's crazy insight, Michael. How about yourself?
I think Adam, that's basically
kind of nailed it.
Yeah, he's got it. He's locked in. I will ask Adam, when does the Chariot like compute stack integrated Apple style into the battery come out? Like when can I just plug into the Chariot Jetson that's integrated into the Chariot battery? When does that happen?
Yeah, so I mean, the great thing is that we're gonna be able to kind of work with those mission partners, and I kind of mentioned those three kind of lifeblood systems, right? Like having those integrated definitely makes a lot of sense. I very much had a lot of scars from going through the ATO process and going through like FCE spectrum coordination stuff, and so I said, like, I am not doing that with the first product we build. This is going to require no airworthiness, no FCC coordination, no ATO. We'll provide an Ethernet port that you can handle the transport, you can handle the compute. But yeah, there's certainly an eventual kind of natural evolution to say, continue to integrate that core horizontal stack into one. So.
Good stuff. All right. We're going to wrap on that and transition to our final segment, which is the 5-second scramble, which is really just kind of rapid fire Q&A. Sean, why don't you lead us off with Michael, and then I will close with Adam.
Yeah, I'd love to. So I'm very excited, Michael, to do this 5-second scramble with you. the general outline is I'll ask you a question and then you have about 5 seconds just for a quick answer. So don't make them too long. And these are mostly fun. Nothing too in depth here.
Mostly fun.
So the first one I got to ask is, what's the biggest misconception people have about directed energy and lasers when you're talking with them? What's their Hollywood perspective on what your system can do that's completely wrong?
Yeah, you can put like a silvered mirror on the drone.
it'll just bounce off, no problem.
I have like a 9-page technical write-up that I wrote and shipped out to literally like 200 VCs that are in my email list, and I'm like, you need to stop asking me this question.
Hilarious.
Probably also that they expect it to be like Star Wars, where you actually see like the blaster shots.
Yeah, exactly. You see it. That's like
right.
A single shot. And then everyone is over 50, so they're all talking about like sharks with laser beams. I want to die. Stop. Just stop.
Outstanding. All right, I'm glad we've learned some more about lasers then. What's the best decision you've made under serious time pressure?
This is going to be longer than 5 seconds. I have to think about it.
So you're kind of failing this time pressure right now, but it's all right.
Yeah, exactly. The best decision I made under serious time pressure. Oh, some like key hires where I had to make decisions on what we wanted to bring in and being leaders in our company. And it's just like experienced person versus like 22-year-old guy. And then the 22-year-old is just, I just end up vibing it out. And then that guy's just cracked out of his mind. Like he's gonna be like a VP of engineering at like Google someday for sure. So
awesome. What's one skill that you developed that you thought was useless, but then later on it turned out to be very valuable for you?
I'm an engineer, man. Marketing's so important. It's so good. It's so good. We have a marketing lead on our team. It was like in our first 10 hires.
Hell yeah.
Yeah, just so good. So important for recruiting, for sales, for customer education, everything. I mean, our LinkedIn's got like 6,000 followers and we're like not that old or big of a company. So we punch above our weight for sure in terms of our marketing.
That's awesome.
That's a high leverage answer from a former engineer to admit marketing is important. Good for you, man. What's a failure that taught you something that you still use today?
Not letting people that are probably, you kind of know in your gut are not going to make it, spending too long keeping them around, not letting go of people earlier.
Gotcha.
But we're good on that now. But early on, growing pains.
This one kind of calls back to the first question about lasers, I think, although I could be wrong. I don't want to lead you too much. But what's the weirdest thing that you've had to explain to a room full of generals or SES's executives?
The mirror question.
The mirror question.
Keeps coming back to the mirror
question. They're like, dude, the light gets reflected. All light's the same, right? Yeah. Yeah. So this 2025 has been about customer education, man, in a lot of ways. So, yeah.
All right. You're out of the harder questions. We're going to get into some pretty easy ones now, Michael. What's your go-to stress food when you're deep into a project, when you're pulling some all-nighters?
Zins.
Not technically a food, but we'll accept that answer.
Just swallow them down.
Cool. Yeah. There's a non-zero amount of calories in that. Yeah.
All right. Definitely. Yeah. I got a crack team over at over with Michael. What's the best podcast or newsletter recommendation besides the pair program that you'd recommend that has nothing to do with defense or technology?
That has nothing to do with defense or technology.
Yeah, just a random other podcast or newsletter.
This Car Pod with Doug DeMuro. I'm really into cars, and Doug's got a podcast. It's goated with the sauce. It's real good. Talks about like how do you get like what's the strategy for trying to get like a 2008 Cayman manual that's not totally bore scored and destroyed for like less than 20 grand, and how do you kind of like finagle that? So that's my personal thing right now.
Awesome. If you weren't in defense tech or in automotive world, what do you think would be the industry you'd be most interested in besides those two?
It would be in photonics still. So I think that basically all compute is going to go away from the electron and it's going to go into the photon. where the bandwidth and the band rates that you can get through optical interconnects, like all the data centers are going into photons. My old company is like, I think their stock's doubled in the last year on selling optical transceivers, and like they're a core part of the fiber and optics part of the AI data center grow out. So we're gonna have like computers that just run on like photonic silicon chips.
Okay, but if I put a mirror inside the computer, then it's done, right?
That's low power density. It probably would work. It probably would stop. Like if you put it in the yeah.
What if you put the mirror on the shark's head?
Yeah,
on the shark's head. Okay, you're killing me.
And then I like to end always with our standard question, which is there a charity or a philanthropy effort that's close to your heart that you want people to know about?
I would say you should go start a factory and employ like 1,000 people.
Awesome. Yeah. Well, thanks for doing the 5 Second Scramble, Michael. You crushed it.
Thank you.
All right, Adam, you ready?
Ready.
Before we jump in, I'm going to do a quick plug for our sponsor, Zen. I feel like we've said Zen about it.
No way. Are you sponsored by Zen?
No, dude. I wish. I mean, maybe we'll see after this episode.
It's
after this one.
Yeah. Please.
I saw Michael's eyes light up. That was great.
No way.
Each of you gets a lifetime supply. All right, Adam, you ready? Explain Chariot Defense to me as if I were a 5-year-old.
All right. So I'm thinking back to the kids' toys. Like, so, all the toys you have, you have to put batteries in those toys. You have to plug them into the wall. What if you were out camping and you didn't bring any batteries and there was no wall to plug into, and then you couldn't play with any of your toys? That would really suck, right? So I guess I can't.
There it is.
Yeah, there it
is. There it is.
That'd be sad.
How would you describe the culture at Chariot?
Yeah, I think the culture is, we try to really focus on, and kind of tying back into the defense thing, just like really clear communication of like limitations. Just like no one really feeling the need to like oversell kind of their capability, or oversell their like, their knowledge, right? Even just like, very much a kind of culture of transparency, culture of kind of, blameless curiosity, when something does go wrong. And that's really what we try to do. We have a lot of really smart engineers coming in from all different industries, right? We're combining people from the EV industry, the defense industry, right? Traditionally that have not a ton of overlap. And so trying to kind of bring the best of both together. Really great technology, but like really, really good focus on the mission.
That's cool. I like that blameless curiosity. That's good. What kind of roles are you guys hiring for over the next 3-6 months?
Yeah. We will be persistently hiring electrical engineers, software engineers as we start to build out the software platform of this that I didn't talk as much about, but creating that kind of operational energy visibility layer and data layer and like microgrid management. So building out really focused on some software, some kind of key software and electrical hires as we make those big investments.
Nice. What's one of the biggest lessons that you took from your time at Anduril or Uber that kind of stuck with you when building Chariot?
Yeah. I think kind of tying back to the with Anduril, I think what Anduril did really well, and kind of one of the secret sauce kind of components there was really, having engineering and BD have kind of equal seats at the table. I think with the primes, you can get very BD driven, where they're going to go sell something on PowerPoint to a customer and then just like throw like a spec sheet, over the fence to the engineering team and say, build exactly this because this is what I already sold. And then you can also get companies where you just like fall in love with the technology and just like, like Michael was saying, do all the 130 IQ stuff first, and just like become obsessed with that and like don't actually think about, how this actually gets sold. And so, keeping that, that kind of healthy tension between sales and engineering where like, we're pushing the boundaries on what's possible on the engineering side, but we're also making sure it's tying into something that's not only meeting a mission, but meeting a budget line and meeting a procurement office, right? And like, having to think about how do we actually not only employ this, from an end user perspective, but in defense, there's a lot more than just winning over the end users to be successful. So that's really something I've tried to keep as part of a key focus of the team.
That's awesome. All right, finish this sentence. The future of the battlefield runs on blank.
Robots in.
Robots in.
Which is electrons.
What's your favorite way to unplug?
Favorite way to unplug, just going out, walking with the dog, being right there in San Francisco, right along the water, just, getting out, walking around, just having time to think. So yeah.
Nice. Favorite sci-fi movie of all time?
Let's see. I think that's going to be, it might be Spaceballs.
Oh, hell yeah. Nice one. Good pull. What's the best concert you've ever been to?
Best concert. Let's see. I went and saw at Oracle Park, formerly AT&T Park. Saw the Eagles and Zach Brown Band. That was a pretty magical one. It was Eagles, Zach Brown Band, and the Doobie Brothers.
All of them were there. That's crazy.
Yeah,
that's great. Zach Brown's so good. If you could have any superpower for a day, what would it be?
A superpower. Probably teleportation, as I dread getting into a middle seat on my flight back from DC to SFO today.
In TSA, second stringers are out there.
Yeah, exactly. Yeah.
Oh, Adam, when do you leave?
I'm on the 6 p.m. from DCA.
I think we're on the same flight. All right.
Probably. Nice. What's the last one? Charity or corporate philanthropy that's near and dear to you?
So my wife's a dentist, endodontist. She did a lot of work with Operation Smile. So I'll throw that one out there.
Sweet. All right. And then, Michael, I got to ask you, because I saw your eyes kind of light up. What kind of roles are you guys hiring for over the next 3 to 6 months?
Dude, let me top my game.
How much time do we have?
Thank you. So we are hiring for I know exactly what they are. We're hiring for another hardware engineer, another general SWE software engineer. We're hiring for a perception and sensing engineer for edge sensing, a laser design engineer, more in high power fiber laser systems development, and a power electronics engineer right now. So basically everything across the stack. So we get no breaks. But the one thing Adam can give us a break on is not having to make a battery. So I appreciate that about it. Yeah.
It's a big lift. Awesome. Well, that's a wrap, guys. I appreciate you all, spending time with us, expanding a little bit more on what you're building, and giving us a peek at what's next on the modern battlefield. So thanks for joining us on the podcast.
Sure. Thank you, guys.
Thank you. It's fun.